Balancing Chemical Equations and Types of Reactions by Kristen and Hannah.
In 1785, a scientist named Antoine Lavoisier discovered the law of conservation of mass.
This law stated that in a chemical reaction, matter is neither created nor destroyed.
This means that in order to properly balance a chemical equation, the reactants and the products should end up being equal. This means that in order to properly balance a chemical equation, the reactants and the products should end up being equal.
In this example, you see the chemical equation of propane reacting with oxygen to produce water and carbon dioxide.
To begin, you have to write down the number of atoms each element has. You can do this by just looking at the subscripts of the elements.
For this problem, on the reactant side, there's 3 carbons, 8 hydrogens, and 1 oxygen. On the product side, there's 1 carbon, 2 hydrogens, and 3 oxygens. Next, you choose an element that's a single molecule for reactants and a single molecule for products. In this case, it's the carbon atom. Since there are 3 carbons on the reactant side, you can balance it out by putting 3 in front of the carbon on the product side.
Next, since there is an 8 behind the hydrogen, you also need to have 8 on this side. And 4 times 2 is 8, so you would put 4 in front of the hydrogen, making both of the hydrogens equal. Finally, you have to balance your oxygens. On this side, you have 4 oxygens in the H2O, and you have 3 times 2 oxygens, which is 6. So 4 plus 6 is 10. So on the reactant side, you need to have 10 oxygens. And 5 times 2 is 10. So here, you put a 5 in front of your oxygen. And now you have your balanced equation.
You know this is a balanced equation because on each side, the carbons, hydrogens, and oxygens all have the same amount of atoms. Now we're going to talk about the 5 types of chemical reactions. They are synthesis, decomposition, single replacement, double replacement, and combustion.
The first one is called synthesis. This is where 2 or more compounds combine to form just 1 compound.
The second type of reaction is called decomposition. This is where a complex molecule breaks down to make a simpler one. The example is AB reacts to create A plus B.
The third type of reaction is called single replacement. This is where one element trades places with another element in the compound. In this example, A reacts with BC and creates AC plus B.
The fourth type of reaction is called double replacement. This is where anions and cations of 2 different molecules swap places, which then forms 2 different compounds. The example is AB plus CD produces AD plus CB.
The last type of reaction is called combustion. This is where oxygen forms with another compound to form water and carbon dioxide. The reactions are exothermic, which means they produce heat. The example is C10H8 reacts with 12O2, creating 10 CO2 plus 4H2O.
Thanks for watching. We hope you enjoyed our presentation.